All right, in this equation, we're going to solve two radical equations. These equations over here are called radical equations because of the variable being under the square root. And our main goal is to take care of this square root. And generally, to undo the square root, what we're going to do is to square both sides of the equation. So in this first one, I'm going to, right out the gates, square both sides of the equation. And I'll show you what that result is. From the left-hand side, the result of this squaring is that that square root goes away. On the right-hand side, I need to FOIL this out. This is x plus 17 times x plus 17. After I multiply all of that out, what I get is x plus 34x plus 289. And again, where this right-hand side comes from is from me doing all the multiplications necessary in this statement right here, because that is x plus 17 squared. All right, this is now a quadratic equation, so it went from a radical to a quadratic. And so I'm going to set one side equal to 0. And then my goal is to solve this. I could use completing the square, quadratic formula, or factoring. I did this a second ago, so I'll just show this by factoring. It's set equal to 0. Two factors that multiply to be 140 and add to be 33 are 28 and 5. So this factors into x plus 5 times x plus 28. All right, and then as a quadratic, we would set each of these factors equal to 0. And those would give us the two solutions of x equals negative 5 and negative 28. Now we've come to one of the most important things in radical equations, is this process right here of squaring actually is not a bijective operation on this equation, mainly meaning we could have fake solutions or extraneous solutions in this equation right here. In other words, this equation we have after squaring is not exactly the same. It's pretty dang close, but not exactly the same as our original equation. The only thing we need to do is to check our solutions to ensure that we got them right. I'm not going to show all those steps here on the video, but I'll show you the work but not work through it slowly. The game looks like this. I'm going to take negative 5 and negative 28 and plug them into the original version of the equation, and just check to see if it makes both sides of the equation equal. The goal of finding a solution to an equation. Give me a second and I'll produce those solutions for you. All right, and here's the work for plugging these back in. Again, I plugged both the negative 5 and the negative 28 back into the original equation. And lo and behold, one of these is not a solution. X equals negative 5, when I plugged that in, gave me out that 12 equals 12, meaning it's a true solution to the equation. But negative 28, when I plugged it in and worked it out, gave me 11 equals negative 11, which is not a true statement. And so this is an extraneous solution. In other words, it's not a solution to our equation. All right, let's talk about number 2. For number 2, what I first need to do is to isolate the radical part. This is often a move that we're going to have to do with different types of equations, absolute value equations, for instance. What we're going to do is I'm going to first add 4 to both sides of this equation. That will get rid of this 4, the subtraction of 4 over here, and we'll just add 4 to this right-hand side. And so I'm going to have is 4 times the square root of 6x minus 2 equals 4x plus 4. And then what I'm going to do is divide both sides by 4 to get rid of this 4 out in front. I actually don't have to do this move. I could just square both sides now, but this will clean it up a little bit, make things a little bit easier for me. And so what I get on the left-hand side here is the square root of 6x minus 2 equals x plus 1. And now I can square both sides. So I have isolated the square root. I'm going to square both sides of the equation. Again, squaring this left side will just take care of or get rid of the square root. And then I need to make sure I do binomial multiplication on the right-hand side here for when I square. So what I'll get is 6x minus 2 equals x squared plus 2x plus 1. set this equal to 0 and factor. Hopefully that it works out nicely, so I will do that now. All right, so I got my solutions of x equals 3 and x equals 1. Extremely important again, and I won't show those steps now, but you can try them out yourself. I do need to plug these values back into the original equation so that they just check that they do work. Though I can verify that both of these solutions do work. Again, the steps are: make sure you isolate the radical, square both sides of the equation to get rid of the square root, solve whatever remaining equation you have, and always be sure to check your solutions.